Right, just a sound check. Let me know if you can hear me out there, people that are watching. Okay. I will wait a minute. We have a student that's logging off and logging back on. Are you back yet or not yet? Okay. Okay, they are back. Let me know if you can hear me once you've connected. I'm assuming that you can. We're going to look at our next example, and this is an example that I pulled off the web, and I think it's a good example. It's a little more advanced than the examples we've covered so far, but you know, that's sort of how it should work, right? That we build up from simpler to moderate examples than to a little more difficult. And so we're going to explore a few concepts in this one. And it is available on Canvas. I have a link to it. And we're going to do the real-time weather application here that's found here on Canvas. So if I click over to do this week for week 5, we click on this, we'll get a list of projects, and all these projects are good for you to view. There's a calculator, there's a clock, and so on. These are all pretty interesting. The one we're going to focus on for this class is real-time weather app. And when we click on link to source code, we get sent to GitHub. And GitHub is a repository where people can put their code that they want to share, or possibly share only with a certain group of people or whatever. I think you can do that with GitHub. Thing about this is I can look at the code. If I wanted to make changes to the code, I could check out the code and then check it back in. And that mechanism would prevent 2 people from making changes on the code at the same time. I believe this one we can't check out because this person wants control of it. But anyhow, to get this code, we click on code and we click on download, and we can get a zip file from it that I'm going to go and save to the desktop. You can also open with the GitHub desktop application if you wanted to do that. But this is definitely something worth exploring. You know, you can take a look at it on your own time. We may come back to discussing this at some point. So I expand this code and I'm going to extract it. And we end up with this code. All right. And we'll notice that there is a JavaScript file. This is the first example I think we've seen where the JavaScript code was separate from the HTML code. There's a README, there's a style, and there's an HTML, and then there's some of the other things that go along with this, icons and the font and so on. Let's see how this runs. When I double click this page and bring it up, first thing it's going to do is going to ask me if I want to share my location. There is mechanisms within the Java API for getting your location, and depending on whether you are on a desktop computer connected to the internet or you are on a device that has a GPS, this location will either be fine-tuned or not particularly fine-tuned. I think in this case it's not going to matter. It's going to show me as being in Elyria. But if I block the location, I will get an error. I'm going to allow the location, and what the page is going to do is it's going to load up my weather. All right. And it says that the current temperature is 17 degrees Celsius, clear sky, and we're in Sheffield, USA. If I click this, it converts it to Fahrenheit. Now this is real time, all right? Based on what we said in this class, excuse me, based on what we said in this class, you can imagine that the access to the actual temperature and weather information is not something that happens on the client side, but it's something that happens on the server side. All right, so this is a first example of code that we have that integrates both client and server code. All right, so let's look at this in more detail. The HTML is very rudimentary, very basic. If we look at that, we will see that there is things about the style, the font, all right? But the page really doesn't have a lot on it. It has, let me try to make this a little bit bigger. You can see pretty much the whole code. It has a container div, title, a div that has a class of notification, div that has a class of weather container, a div that has a class of weather icon, a div that has a class of temperature value, a div that has a class of temperature description, and a div that has a class of location. So it essentially has the shell of these divs, and initially these don't have anything in them. All right, the icon is unknown, that was a question mark, and the other fields are blank. So we have divs that have these things, and they're styled very nicely using the CSS that we have up here. I'm not going to go over the CSS because we have bigger fish to fry, so to speak. All the action that we're interested in takes place in this app.js. And you notice this is how we can integrate a JavaScript script file into our code. It's again with the script tag. Instead of having the text of the script in here, we have a src equals, and we have the file that contains the script. So let's open that up. And I'm going to hit the highlights with this. All right, I'm not going to cover necessarily every little detail with this. Because if we look in Canvas, there's a video where the author covers this in detail.
Before we were using Monday.com, our team was drowning.
After we get through the app.
I stood in work and managing work, but Monday.com just took care of all of the management. So we could.
So there's like a 38-minute video that covers this. And it'll cover in more detail than I'm going to today. I want to hit the high points, and I want to focus on the things that we have not talked about in class and the key points that I want to emphasize as far as this application goes. But you can get more details by watching this video. All right, let's look at the JavaScript file. First thing that we're going to notice is this code is outside of a function. All right. Now, what that means is this code is going to execute as soon as the page loads, or actually it's going to execute while the page is loading. All right. Actually, what I would do if I was coding this is I would create a window on load event and put this code in there just to make sure that we didn't run into any difficulty where the code tried to execute before the page was loading. All right, we set up some constants. Icon element is document query selector dot weather icon. Okay, what does that mean? That's another way of getting a pointer to an element of the page. We in the past have used something like this. the way we would have written this in the past, constant simply means it can't be changed, is we would have said something like this. Icon element equals document get element by ID, and given the value of the ID. And then we would make sure that that thing on the page has that ID. This does about the same thing. The line above it, query selector. What is meant by a query is the selector like you would use in CSS. In other words, what this is saying, dot weather icon, is this is saying, give me the thing on the page that has a style of weather icon. How do I know it's a style? Because I say dot weather. And dot weather in CSS, or dot weather icon rather. And dot weather icon in CSS would mean the thing that has a style of weather icon. So that's going to pick up this thing here. Now I said it's essentially the same. The only time that this would be different is if there were multiple things on the page that had that class. Remember, an ID on a page needs to be unique. That is, you can only have one thing with that ID. A class you could actually put in on several elements. So this code right here sort of depends on the fact that there's only one thing on the page called weather icon. If there was more than one thing on the page that had an ID of, or that had a class of weather icon, if there was more than one thing that had a class of weather icon, then this statement would actually return an array or a list of elements. And I think the code would break at this point. Okay. So, at any rate, they've ensured that each of these things is unique. In other words, there's only one thing on the page with a class of weather icon. There's only one paragraph on the page that has a class of temperature icon, and so on down the line. I would say that's an argument for using document get element by ID, because an ID is supposed to be unique and you don't run into the potential of there being more than one thing on the page with that ID. So all these things do are get a pointer to these different elements on the page. These elements through here, which correspond to these different elements on the page. All right, what's the next thing that we do? The next thing we do is we create essentially an object. All right. And an object, as we might know from other languages, has properties and methods. Here we're saying we have a thing called weather, and it has a property called unit, or has a property called temperature, which contains the unit Celsius. We have a weather object, a property called temperature. The value of that temperature is a unit in Celsius. We'll see how we use that a bit later on. We set up a constant for Kelvin. This API, which we'll get to in a minute, returns the temperature in Kelvin. And we have to convert that temperature to centigrade and Fahrenheit. And then finally, we have an API key. So what is an API? We look for a definition of API. API says is an application programming interface. It's a way for two or more computer programs to communicate with each other. So if we look at our web page, we have our web page that communicates with some weather service out there on the web. We're not writing the code to grab the current weather, to pull this. We're using someone else's code that has the weather information about different cities around the world. So we need to communicate with the weather application. And the way we do that is through the API, right? Now, an API is like a set of rules. We can look at the API for this weather application here. And this shows an example of an API call. In this API call, it shows us, hey, if you want to get the weather for a certain latitude and longitude, this is the address that you have to call. You have to request that almost like you would request a web page, but you're not going to get back a web page. You're going to get back a chunk of data. So this is how you access the data from the weather application that's out on the web. You need to supply a latitude and longitude, right? And an API key. Well, they've given us in this example the API key. It's this key here. You can actually go to this site and sign up and get your own API key if you wanted to. But since we're just doing this for educational purposes, we'll use this guy's API. So we're going to make that request, and we're going to include the latitude and longitude of our current location along with the API. So we're going to structure and form a request that looks like this. And this is what we're going to get back. So for example, this does the location of latitude of 44.34, longitude of 10.99. And that apparently is someplace in Italy. It doesn't give us a city. And it tells us these are the coordinates. This is the weather. It's rainy there. This is the icon to use. This is the temperature. Now you might say 298 degrees, that's pretty hot. Well, no, that's in Kelvin. And to get centigrade from Kelvin, you subtract that constant, or you subtract 273. So this would be like 25 degrees Celsius. We then have what it feels like. We have the high and the low, pressure, humidity, and so on down the line. So what is this monstrosity of data? This is known as Json Data. And JSON stands for JavaScript object notation. So instead of a web page back, we're getting this data in this format. I saw we had a question. Let me check that. So is the app accessing the location to grab the proper API key? No, the API key doesn't relate to your location. Every request we have will have our personal API key. That if we signed up for an account, we would get that. Or in this case, we're using the example API that this guy provided in his example. So we are going to pull location from the browser. All right. The API key is a constant. It relates to who is making the call, not what the location is. if that makes sense. Okay, so this is the data that we get back, and this looks very intimidating to see this, but there's a very simple way of accessing data from this JSON data that we'll see. So, like everything in client server, there's a request and a response. This is how you make the request. This is what the response is going to look like. All right, let's get back to our code. This is looking to see if our browser supports geolocation. Pretty much all modern browsers, from what I know, support geolocation. So this is kind of older code in here. So this is simply testing to see if the browser supports geolocation. And if it does, it's going to get the current position. So this is what it's going to, the current location. This navigation.geolocation.get current position. And what is set position? Set position is if the browser can determine the latitude and longitude correctly. Either it's able to pull the latitude and longitude correctly, or it's not able to. For example, if you remember, when that page appeared, it asked us if we wanted to share our location. If I answered no, then the browser would not be able to pull the latitude and longitude. So if it's able to pull the latitude and longitude, we call this set position function. If it's not able to, we call the show error function. And the show error function displays an error that says, hey, we're not able to access it. Let me try to get that error to show you what it does. All right, if I said block, boom, we get that error. User denied geolocation. That's what this code here does. So if we try to pull the location and we get an error, boom, this is what we get. If we had an ancient browser that didn't allow geolocation, we would get this error. And what are we doing? We're setting the style to a certain style, and we're setting the inner HTML of that element, which we defined as a constant up here. The thing on the page that has a class of notification. So if we can't pull the location, we call show error. That grabs the error message, which says that I blocked it. I blocked the location. If it succeeds, it calls get position or set position. Oh, here's set position. Set position simply calls and gets back from the position that's returned from the geolocation. This is where it pulls the latitude. This is where it pulls the longitude. So if get position succeeds, or if the get current position succeeds, this function gets called, and this is where we find the latitude, and this is where we find the longitude. We put that in our variables. Then we actually make the API call. So at this point, we know that we've been allowed to pull the position. it succeeded, and we have the latitude and longitude. So here we're constructing the URL for our API call. Remember, our API call needs to look like this. Needs to look like this. https://API openweathermap.org data 2.5 weather ? lat equals 44.34, long equals 10.99. Substituted with our values, of course, and then the API key. We form that API call request dynamically by popping in the latitude and longitude. This is a nice little JavaScript trick that allows us to insert in the middle of a string the value of some variable. So we're filling in the blanks. All right. The first part of the API call is hard-coded. We fill in the blanks with our latitude and our longitude and the app key. So if I did this, I log to the console the value of that API variable. Oh, went up a degree to 18 Celsius. If I look at the console, I'll see what that call looked like. And that's what it looks like. All right. The hard-coded part with the latitude and longitude filled in, along with the API ID. So this is going to be the request that gets made to the server. This is the actual code which calls a server. And we have several clauses in here, then clauses, to make sure that everything processes correctly. This is simply defining 3 steps that we're going to do. And this step won't happen until this step is finished. So, when we retrieve the data, when we make the API call, we're going to take what gets back from the API call and put it in a variable called data. And that data is in JSON format. After that has happened, then we're going to process the data. When this gets done, then we're going to display the data. Let's look at these one at a time. What this is going to do is this is going to take the response we get back from the server and put it in a variable called data. And guess what? We can log this to see what we get. All right, we get back an object that has a whole mess of stuff in it. All right, and here we actually finally see the actual weather. We get back the result in an object, and notice if we look, this object looks a lot like the object that we have in our API, because that's the format. There's first something called coordinates, a lot of longitude and latitude. Coordinates, latitude and longitude. There's something called weather, or there's something called main, all right, with temperature and so on. And we can see main with temperature, feels like temperature minimum. This is simply showing us that it is returned what was promised to be returned when we make that request. All right, okay. So what's next? We're going to fill in this data object. We're going to create attributes in this data object we declared way up here. Remember, we set only a single attribute up here, a unit of Celsius. We are going to fill that in then with stuff from our data. Now, notice this says the temperature, for example, we're filling in the value of the temperature and we're setting it equal to the data, from the main section, temp, minus Kelvin. Kelvin was at constant, 273. So if we look back here, we take 291 and subtract 273, that's where we get the 18 degrees Celsius. Now, how did we know to say data main temp? Well, we know the result from this API call is in the variable called data. Let's look at the return value from this. This is data. Coordinates are in data.coord. The weather's in data.weather. The temperature's in data, that's this thing, .main, .temp. So we're using dot notation. If we wanted to know, for example, the high or low, that would be data.main.temp min or data.main.temp max. If we want to know the humidity, it would be data.main.humidity. If we wanted to know the visibility or the wind, let's say, the current wind speed would be data. It's not contained in wind in main. It's contained in wind dot speed, and so on down the line. So we use dot notation to get to this. I could put another log here. So we're pulling the temperature from the data that we got back in the main section in a variable called temp. So this dot notation means getting more and more specific. All right, 291. We take that minus 273, we get our 18 degrees. This simply fills up these variables. The name of the city is in data.name. So if we look at the API, data. This example doesn't have a city, but if we looked at our example, data.name, this gives us a nice little display. Data main temp. The root of this object is data, and then from there we go to .clouds or .coordinates or .main and get the temperature minimum and maximum. And if we notice, the .name is Sheffield. So that's where it gets the name for that, and it gets the country from .sys.country. Sure enough, that's what it shows. And then we call display data, display weather rather. When we call display weather, that simply sets these inner HTMLs. It uses the icon ID, which came from data weather sub-zero icon. Sub-zero is there because there is a potential to have more than one weather thing shown, like if you did a multiple day forecast, probably. All right, so we get the icon ID and we pull that and construct this image tag by taking icon slash the icon ID plus PNG. So if we look at this, in icons, we have these different icons that correspond to the icons that we'll get back from the server. So we construct that image tag. We output the inner HTML for the temperature, for the description, and for the city and country. The last thing we have is we have an on-click event that's going to convert the temperature between Celsius and Fahrenheit. So if we click on it, it goes to Fahrenheit. If we click back, it goes to Celsius. This is an on-click event that we add to our button. This is what's called an anonymous function. We don't give the name of the function. We simply declare the function right in the middle of code. And it uses this Celsius to Fahrenheit calculation to convert it to Fahrenheit. Now, let's look what you have to do for your next lab. This might be intimidating. Watch the video that will explain this to get sort of a second perspective on this. And hopefully that will clarify some of the questions. Put console log statements at different points to see where different variables are. And that might be useful. Ask questions if you don't understand. Come to lab, either in person or virtually. All right. But here's what you have to do for your next lab assignment. You have to, first of all, remove all the code. You're going to make a copy of this. You're going to download it, like I did. You're going to make a copy of this. Then you're going to remove the code that retrieves the weather data for the current location. Okay? In other words, you're going to get rid of the code that grabs the current location and sets the position and show air for that matter. Because we're not going to be using the current location to determine the weather. So you're going to remove that code. You're going to add a text box for city along with a button. And when the user clicks the button, you're going to make the API call to retrieve the weather for the entered city and display it. And you're going to add the high and low temperature to the displayed output. All right. So what does that mean? All right. I would imagine you should be able to do this. Remove the code that retrieves the weather for the current location. I imagine you could add a text box. I imagine that you can add an on-click event. How do you make the API call to retrieve the weather for the entered city? Well, look at the API definition. This is how you retrieve for a given latitude and longitude. But if you look over in this navigation, this is how you make a request to retrieve by the city name. There's a couple ways to do it. This is probably the easiest one. So you're going to need to make the call not using the latitude and longitude, but using the value that you pull from that text box and pop that into the city name in this API call. Now, when you make the API call, the result is going to look the same. That is, it's going to be put in, it's going to be in JSON, it's going to be put in that data variable, and it's going to have the same attributes as before. And you're going to pull those attributes. In addition, you're going to have to pull the high and the low temperature. And we already looked at how you do that. When we looked at the result from the API call. It's shown somewhere here. Shown on the other one, I think. Yeah. High and low is in the part of the data, is part of the section main, and it's called temp min and temp max. And it is in Kelvin, so you will need to convert that to centigrade to make that consistent. When you click on the temperature, you'll need to convert the high and low to centigrade or Fahrenheit or whatever also. So you'll need to keep showing the temperature in the same units as you're showing the main temperature. So the first step I would say is understand as well as you can the current code in the example. All right, review this lecture. Log things to the console that will help you see the progress of the page as it's loading. Watch the video. Ask questions. This is not a simple assignment, right? But it is easier to simply make a tweak to this page than doing a complete API call from scratch, right? Does anyone have any questions? As a general rule, would you suggest always using get element by ID versus query selector to avoid naming issues? I would say use get element by ID. If the thing on the page you're looking for has to be unique. All right, in this case, like the icon that we're displaying, that has to be unique. All right. In this example, if there were two things on the page that had a class of weather icon, this code would blow up. So in this case, yes, weather icon has to be unique. And if it has to be unique, I would use get element by ID. Now keep in mind that is only if it has to be unique. There could be JavaScript code that we would write where we would want everything, even if there's multiple things of a certain class. Maybe we're going to change every, I don't know, every image caption to a different font, let's say. All right. In which case we need to pull not just one element, but a list of elements. And in that case, I would use Query Selector. It is valuable, I think, to see how Query Selector works so that if you see it in other examples or if we cover it next week, you'll have a heads up on how that works. So great question. I would say yes. I would always say if it has to be unique, then use an ID because the ID is guaranteed to be unique. Key to doing this is doing this a bit at a time, right? The first thing that you need to do is pull the code that retrieves the data for the current location. Well, if I'm not retrieving from the current location, I don't need this. And I don't need that navigator. I can get rid of all of this. And save it. Then when I load the page, it doesn't load the current location. All right, progress. Next thing I will need to do is add a text box. I imagine we can all add a text box to the page. Now, we have a function to get the weather data. That function accepts a latitude and longitude. We're not going to have a latitude and longitude. We're going to have a city name. So we're going to change this function to accept a city instead of a latitude and longitude. And we're going to change the API call not to pass the latitude and longitude, but to pass the city. With relatively minimal changes, you should be able to get this to work, all right? By keying in a name, get it to work exactly like it's working now. That ought to be the first step that you try for. And then start looking at adding the additional fields. Are there any questions at this point? Right, just as a word of caution, if you're having trouble with these assignments, you need to get a hold of me. I know this is a blended class where you don't have to attend and you don't have to attend lab. I do that because that accommodates many students' needs. However, if you need the time with me, either online or in person, please make an effort to do so because that time is available. I'm not just available on Monday and Tuesday. I'm available virtually at most times throughout the week. So the other half of the blended class is not just that we have lectures only one day, but that there are online materials and I'm available outside of class to address your issues. So please take advantage of that. All right, that's all I had for today. Please let me know if you're having trouble with anything. Have a good week. We'll talk to you next week or maybe before.